All right. When you see a binomial like this, and you're told to write it as a polynomial, what's the first thing that comes to mind? Foil. Foil. So you could FOIL this. X times x is x squared. Outers is plus 12ix. Inners is minus 12ix. What happens to the outers and the inners? Cancel. And then minus 144i squared. Well, what's I squared equal to? -1. So it's 1 minus 144 times -1. Well, this is the same as x squared plus 144. So this equals x squared plus 144. Okay, what are the zeros of the function? Well, there are no zeros because the only roots are imaginary roots. So when you have imaginary roots, it's like a parabola that doesn't hit the x-axis. Okay, it would look like that. Again, you see this and you go, well, these two look alike, so I'll FOIL those two. Excuse me. Those two look alike, so I'll FOIL those two. The first two is x squared minus 25. The second two is x squared minus 49i squared, which is the same as x squared, and then what follows that?
Plus 49.
Plus 49. So if we FOIL this, we get x to the fourth. Outers is plus 49x squared. Inners is minus 25x squared. So it'd be plus 24x squared minus whatever 25 times 49 is. Big number. Okay. Does this function have zeros? Are all the roots imaginary? Are all the roots imaginary? No. So it does have zeros. It has zeros at 5 and -5 because of these two. Whoop. Nope, just 5. Oh, Mr. Bierschbach made a colossal mistake, didn't he? This is all wrong. Not all wrong, but mostly wrong. Mr. Bierschbach made a colossal mistake. I thought it was x plus 5x minus 5. It wasn't. It was x minus 5 times x minus 5, which is x squared minus 10x plus 25. And then we have x squared minus 49. So then we have to double distribute. So we get x to the fourth minus 10x cubed plus 25x squared, and then minus 49x squared plus 490x minus 1225. Negative 49 times a positive x squared is a negative 49x squared. Yeah, it would be. John, thank you very much. All right. So I'm really good at making mistakes this afternoon. So it'd be x to the fourth minus 10x to the third plus these two would add up to be 74x squared minus 490x plus 1225. Okay, that's the expression. 5 would be a 0, so what's the x-intercept? 5 would be the x-intercept. All right. Now, if your roots are 6i and negative 6i, that means it's x minus 6i and x plus 6i. And you can write your polynomial function pretty quick from there to be x squared minus 36i squared or plus 36. Okay. Now, as we keep going here, there's another way to do some of these. Okay. So see how we have 3, negative 8i, and 8i. And so yes, it would be x minus 3 times x plus 8i times x minus 8i. Okay. And you could, again, FOIL this out to get x squared plus 64i. Another thing you can do is follow a pattern called sum of the roots, product of the roots. Okay? So, if we just look at these two, it's x squared minus the sum of the roots times x plus the product of the roots. So if we use that pattern, what's the sum of negative 8i and 8i? 0. What's their product? Well, it's negative 64i squared or a positive 64. So then it's x squared minus 0x plus 64 or x squared plus 64. Now, could have we gotten that by what we've been doing so far? Absolutely. But this is just another way to look at it for more complicated problems that we're going to get to. Now, if we have this and we have 3 as another root, we have to multiply it by x minus 3. So we get x to the fourth, x to the third, I should say. First times first. And then I'm going to do inners next, minus 3x squared, so I get highest to lowest powers, plus 64x minus 180 and 12, 192. Okay? Actually, it's on this one. All right. So find a polynomial with a leading coefficient of 1 and zeros of 2 and 2 plus I. This is where, if you go x minus 2 times x minus 2 plus I, and then x minus, and then you, imaginary roots always come in conjugate pairs, so it's x plus 2 plus I, or 2, negative 2 plus or minus I. Yeah, either way. It's easy to make sign errors here, okay? So instead of doing this and a really complicated, this is where we use sum of the product of the roots, because our roots are 2, 2 plus I, and negative 2 minus I, because they always come in conjugate pairs. Ooh, 2 plus I? No, I think it would be 2 plus I and 2 minus I. So if we take these two, what is the sum of these two? What is their sum? 4. 2 plus 2 is 4. I plus negative I cancels. What is their product? If we FOIL this, 2 times 2 is 4. Outers and inners cancel. I times negative I is negative I squared. So 4 minus I squared is 4 plus I squared, or 4 minus a negative 1, which is 4 plus 1, or 5. So we have x minus 2 times, and then if we use our formula of x squared minus sum of the roots x plus product of the roots, x squared minus 4x plus 5. And then we have to FOIL out that. So x times all of them is x cubed minus 4x squared plus 5x. And then minus 2x squared plus 8x minus 10. Or x cubed minus 6x squared plus 13x minus 10. So some of these problems get a little bit, they have a few steps to them. All right. Let's do number 7 here. 4 has a multiplicity of 2, which means it's x minus 4 times x minus 4. 2 plus I has a multiplicity of 1, so 2 plus I and 2 minus I are roots. So then we take these two and find that their sum is 4 and their product is 5. So then that's x squared minus 4x plus 5. We FOIL this one out to be x squared minus 8x plus 16. And then we have to triple distribute this one. So if I take x squared times all of these, let's go down 1 point. We get x to the fourth. X squared times negative 4x is negative 4x cubed. X squared times 5 is plus 5x squared. So I'm done with the x squared. Now I'm taking negative x times x squared, which is negative 8x cubed. Negative 8x times negative 4x is plus 32x squared. Negative 8x times 5 is minus 40x. 16 times x squared is 16x squared. 16 times negative 4x is negative 64x. 16 times 5 is plus 80. You add those together. Okay.
What does the multiplicity mean?
Multiplicity means how many times does it happen. So this one would be x minus 2 times x minus 2. And since this has a multiplicity of 3, it'd be x plus 7 times x plus 7 times x plus 7. Because it happens 3 times. Okay, that's multiplicity. So you could write it as powers if you wanted to.
Wait, if it was the 2 plus I, like a multiplicity like 2, then there would be 4 of them?
Yeah. All right. So graphs and multiplicity. Okay. So if it has a multiplicity of 2, it's going to bounce If it has a multiplicity of an even number, it's going to bounce. If it has a multiplicity of an odd number, it's going to go through. So at -2, it's going to bounce. At 4, it's going to go through. Which one bounces at -2 and goes through at 4?
Top right.
This one right here. This one matches with this one. Okay? Which one bounces at -1 and goes through at 3? Bounces at -1 and goes through at 3. This one right here. Which one goes through, because it's a multiplicity of 3, goes through at -2 and bounces at 4? Goes through at -2, bounces at 4. Upper right. And then this one goes through at 3 and bounces at, or goes through at -1 and bounces at 3, which is that one. Okay. So for this one, how many roots does this have? If it has an x squared. 2 roots. 2 roots. Okay? To figure out how many real roots it has or how many complex, we can simply graph it. Okay? If we look at the graph of it, we get 0, 13. If I go 1, I'm at 1 minus 4 is -3 plus 13 is 10. If I put in a 2, I get 4 minus 4, which is 0. 4, right? Minus 4 is 0, plus 13 is 13 again, and so on. So it's a parabola kind of like this, I think. No, I was wrong there. 2 is 4 minus 8, which is -4, plus 13, which is 5. There we go. And 3 would be 9 minus 12, which is -3, plus 13, which is 10. So it's a parabola that goes like this. Okay? How many real zeros are there? 0. How many complex zeros are there then? Well, there's 2 complex zeros because this is a secondary equation. So it has at least 2 roots. None of them are real because it doesn't cross the x-axis. So then there's 2 complex ones. Okay? Okay. This one will take you a little while to do. But I know you are teenagers and have nothing else in your lives besides pre-calculus, so you still have 20 minutes to work in here. You guys working on your quiz, get done with your quiz. Otherwise, let's get started on this. Daniel, get done with your quiz, please.
Well, I get it. No, I didn't. I didn't know that. I didn't think of that. This one's all Oh, what do you put down for the zeros when there isn't any?
What do you mean? There's a button that says none.
Oh, okay.
Yes, you can.
Yeah.
On this one. For those, so that was wrong. And there should be 4, shouldn't there?
Yeah, so go 2, comma 2.
Okay.
Yeah. Mm-hmm.
This is the last one. I just get stuck here when I'm trying to find the rational.
The rational zeros. All right. So you got that,
And then when you do like x plus
but
4,
with it to the 4th power,
yeah, then you have to take them out.
then you do it again.
Except with the other numbers.
So you have 1, -4, -5, 20, and 0, right? So then you try again. Well, you said 4 worked?
Yeah, these 2.
So 4 works. Then 1, 4, 0, 0, -5, -20, 0. So this is x squared minus 5 equals 0.
And solve.
So solve for that. X squared equals 5. So x equals plus or minus the square root of 5.
Thank you.
So if you take it down that far, then it makes it a lot easier.
Thank you.
Yep.
Do you have a worksheet I missed from yesterday? All right, well, thank
There's
you.
is there 2 of them there?
Oh, wait, yeah.
Yeah,
I don't want to be
'cause-
taking them all.
Because he was gone. Darwin was gone.
There we go. All right, well, thank you.
Yes.
Pick that up.
So greatest common factors. So it just
Yeah.
I just had them do the factor trees just like before, and then anything, and then the next one's least common multiples. They'll still do the factor trees, so
Yeah.
they'll have that down really well.
All right, well, thank you.
Yep.
Am I gonna go to the bathroom?
Yes. As long as you are signed out and it lets you. So finding zeros. The zeros of the function are 2 and 2, 2 comma 2 comma 4i, negative 4i.
Wait, so why do you have to put the 2 in twice?
Because the Math Excel is a stupid program sometimes.
So I was right.
Comma, negative 4i. Yeah. This one. Okay. So there's five. The 2 that are real. So just 2. No, it's just 2. Okay.
If it's a multiplicity of three, does that mean it's like it's
It happens 3 times.
so negative 5 multiplicity of three is just x?
X plus 5 times X plus 5 times X plus 5. You can put up your chairs. If you have missings, get them done, please. Hey.
Can you help me on this one? 'Cause I don't know how to do it. So I just get confused. Like, when do I change the i's into the negative one? Like,
After you FOIL them. So the first one is x squared minus 4x minus 4, right? And the next one is x squared minus 9y squared plus 9. Okay? The outers and the inners cancel, so it's x squared minus 9i squared, which is x squared plus 9.
so then I just take like that aspect, then I just take.
I squared is -1, so it's x, because it was x squared minus 9i squared. And then this becomes -1. -1 times -9 is 9.
I think that's what I was doing too. It's like I was squaring it instead of like the whole thing's negative. Okay, that makes more sense. So my calculator is dead.
Bring it back.